Today, it's a pleasure to introduce to you Leslie Banks-Sills. She's an expert in solid mechanics and mechanics of materials, and she will give us a short introduction of her research, and also she will give us her opinion about future trends in this field of research. So thank you, Leslie, for being with us.
It's a real pleasure to be here today and to be able to share with you what I've done in the past and where I think we're going in the future. I'm the head of the Drescher Fracture Mechanics Laboratory at Tel Aviv University. To tell you a little bit about myself, I obtained a PhD from Harvard University in 1977, and then I did a postdoc at Brown University in 1978. And I will say that I quote somewhere that I stood on the shoulders of giants, because at Harvard University, my PhD advisor was Professor Bernard Budiansky, who is very well known. He passed away a number of years ago, very well known. And at Brown University, I was with Jim Rice and Ben Friend, another two important figures in solid mechanics. And then I immigrated to Israel and went to Tel Aviv University. It wasn't called the School of Mechanical Engineering. It was the Department of Mechanics, Materials, and Structures, but we became the School of Mechanical Engineering. But I've been there since 1979. And just to mention, I'm the past president of ESIS, the European Structural Integrity Society. So my interests include fracture mechanics, fatigue, and delaminations in composite materials, which I've been working on, I'd say since about 1995, something like that. And it really holds my interest, and it's really an important subject for people in solid mechanics and materials. One of the big problems today, and we just had a meeting in Glasgow, is greenhouse gas and the reduction of greenhouse gas. And so it turns out that transportation has the greatest contribution to greenhouse gases. And if we can reduce vehicle weight while maintaining, of course, structural integrity, that's what we aim to do, and that's a real challenge for engineers. And we may do this by using composites, metal foams, sandwich panels, adhesive bonding, and lately people have been working on additive manufactured parts. And in this way, we can reduce weight and then hopefully reduce greenhouse gases. So if we take two examples, the Airbus 350, the rear fuselage is made of composite laminates, and the Boeing 787, the fuselage is made of laminates. And in fact, both these aircraft have 50% by weight composite materials. And so that's a way of being fuel efficient, a lighter plane and less fuel is needed. And as far as adhesive bonding, use of it reduces stress raises. It also reduces weight. And the joining methods that we have typically are the use of bolts, rivets, and welding, which of course cause stress raises and increase weight and also increase the complications of joining. Another subject which has recently become important is additive manufacturing, and this definitely reduces weight. And just to show you an example of three hooks, you can see that by optimizing the structure, we're able to save weight because we don't need to have a solid hook. We can have cutouts to and still maintain structural integrity. And so in all cases, bonding, composites, and so on, structural integrity is of prime importance. Now, where are we going in the future? Of course, those subjects that I mentioned also have a future, but recently people have started using artificial intelligence and machine learning to predict failure. And then, of course, the question is, will it work? So that's something that we're going to see in the future if artificial intelligence, if those algorithms can help us to predict failure. So just to leave you with a book, a recent brief book published by Springer on interface fracture and delaminations in composite materials. Thank you.